Welcome back to Lesson 3, Composition of Functions in the unit Composition and Inverse of Functions. So today we're learning something probably that's totally new to you, and that's composition of functions. The other two lessons might have been a little bit of review, but this one's probably totally new to you. Okay, hopefully you've printed your note-taking guide, and I've got 4 functions at the top: f of x, g of x, h of x, and j of x, 4 different functions we're going to use to work through some examples. Okay, so part 1, we're just going to talk about how do you evaluate a function. Well, you guys have evaluated one function before, so let's just start with that, g of 2. Okay, to evaluate a function like g of 2, we would go up, figure out which one's the g function, and just plug in a 2 for x. So let's go up here, and we're going to take the g of x function, which is 2x minus 3. And for x, we're going to plug in a 2. So everywhere there's an x, we're going to plug in 2. So that's going to be 2 times 2, which is 4. 4 minus 3 is positive 1. So the answer to that would be just g of 2 is equal to a positive 1. Okay, so that's evaluating one function. But what happens when we have this composite function? So we need to look at this notation to understand what it means. Okay, composite functions are when one function is inside another function. So what this is telling us is we're going to evaluate the g function for 2, which is what we just did, and then take that answer and plug it into the h function. So you kind of work from the inside out. Okay, so g of 2 is our first step. Once we get that, we take that solution and plug it into the h function. Okay, so we're starting with the option 1, which is just to evaluate one function at a time. So I'm going to take the answer that we just got, which is a positive 1, and I'm going to plug it into the h function. So let's go up here, identify the h function. So we figured out that g of 2 is equal to 1. Now we're going to do h of g of 2. So we're going to take the answer to that, and we're going to evaluate h of 1. Okay, so h function is x minus 2, and we're going to evaluate it for that 1 that we just got out. We're going to plug it in and get 1 minus 2, which is negative 1. So the answer would be h of g of 2 is equal to negative 1. And that's exactly how you read it. H of g of 2 would be equal to negative 1. So one inside the other. Okay? So that's one option. You just take the function and work from the inside out. Okay? Option 2. If you're doing a composite function, you can actually figure out what that composite function is first, then plug the value 2 in. So let me show you how that works. Okay, we're going to take the same example, h of g of x, and evaluate it for h of g of 2. But we're going to start first by finding the composite function. So we're going to take the g function and plug it into the h function. Okay, so what I like to do is I actually like to start with the outer function first, and I like to write this, but I like to leave a blank where the h or where the x is. So my h function is equal to x minus 2. Well, I'm going to leave a big blank where this x is, and I've got to put the g function in where that x is. My g function is 2x minus 3. So I have taken my g function and I've plugged it in for x. Okay, take a second and digest that. I took the g function and I put it inside the h function everywhere there's an x. Now I just simplify it. 2x minus 3 minus 2 is minus 5. So that means my h of g of x function is 2x minus 5. Now all I do is go up and plug in that 2. Now I'm going to evaluate the composite function. So I'm going to take g of h of 2 and plug in a 2 everywhere there's an x. And this one only has one x, so 2 times 2 is 4, and 4 minus 5 is negative 1. I got the same answer. Okay, so you've got two options. One, evaluate the function for the first function for the value, take that solution and plug it into the second function, or write the functions first and then evaluate at the end. You're going to have to be able to do it both ways, so you want to make sure you understand both options. And sometimes it's a little quicker to do the first option. Okay, so then the second part of today's lesson, we're actually going to do finding the functions. So we're just finding these composite functions. We're not evaluating yet, we're just finding them. So we're going to start with g of h of x. Okay, we started with h of g of x, so we started the opposite way. Now let's try it this direction. Okay, so g is my outer function, and I've got to plug the h function into it. So I'm going to start by writing my g function, and I'm going to leave a blank wherever there's an x. So let's go up here, and I'm going to have to leave a blank right here after the 2. So my g function is 2x minus 3. Now I'm going to plug the h function in. Well, what's the h function? The h function is x minus 2. So I'm going to take that and plug it in to that function. So I'm going to put in an x minus 2. Now notice that's a binomial, so what am I going to have to do? I'm going to have to distribute. So that's going to be 2x minus 4 minus 3, or 2x minus 7. So that means, there's my h function, my g of h of x function is simplified down to 2x minus 7. Okay, so that's how we put together and find that composite function. Now let's reverse it. Let's reverse it, and we're going to have h of g of x. So at the h function, I'm going to leave a blank where the x is, and then I'm going to plug in my g function. So let's go up here and leave a blank here. So my h function is my outside function. My g function is my inside function. Okay, so h is x minus 2, and then I'm going to plug in 2x minus 3. Okay, we simplified this a moment ago, so 2x minus 3 minus 2 is 2x minus 5. Okay, now let's try the next one, f of j. Okay, so now we're using two new functions. So f is my outside function and j is the inside function. So let's start by writing the f function, but we're going to leave a blank right here on x squared. Ooh, that's going to be tricky because we have a square around a large function. So f of j of x would be blank all squared plus 8. Okay, so our j function is just a monomial, so it's a little bit easier to plug in. So let's plug in a 5x squared in for that x. 5x squared. Okay, now we have to simplify that. Okay, 5x squared quantity, meaning all of it, is squared. So you have to square the 5 and square the x squared. So that's going to be 25x to the 4th plus 8. So there is my composite function.